Good evening, everybody. We have a very exciting panel here today. They've already been introduced, so I will not take time introducing them, but welcome to Jayant, Manoj, Ravi Kumar, Jigar, Vijay Chandru, and Naganand. So our panel is on developing software and application ecosystems in India, and we will try to focus on this topic. It's not easy. In the context particularly of the theme of the conclave, which is supercomputing. Uh, and that means different things to different people. So let me start off by introducing this as a question to each of the panelists about what are the top two things they think as industry they would focus on. But before I do that, let me just very quickly tell you the kinds of problems which software and a combination of software and hardware can solve using supercomputing. One of the most challenging problems in biology was, and still is to some extent, how a string of letters, and these letters can be, one of 22 letters, how a string of letters can fold in a specific manner always. That string is a string of letters of proteins. Now, each string folds in a specific manner and each protein functions in a specific way. So it's an intrinsic property. Now, this was proposed a long time ago by someone called Anfinson. And another person, Cyrus Leventhal, had a paradox. He calculated the time it would take for 100 letters to fold in a specific manner. And that would take about 10 to the power of 16 seconds, which is greater than the lifetime of the universe. Yet in our body, these foldings take place very rapidly. Now, the theoretical solution to this problem came by a calculation by a Nobel Prize winning chemist called Martin Karplus, who looked at atomic distances in all these small molecules, which are strung together as a large molecule, and provided the theoretical basis for calculating how proteins can fold rapidly. Now, that theoretical basis was not practically applicable until a hedge fund owner, David Shaw, whose passion was computer science and biology, so he understood biology as well. He was a professor at Cornell. He's a billionaire. He developed a computer which had very dedicated processors which could solve this problem, combined with specific software applicable only to this computer. So he translated this theoretical solution to a supercomputing solution, and he has started solving with this computer called Anton, named after Anton Leeuwenhoek, a famous biologist. He started solving protein folding problems. So here is an example of a theoretical solution being implemented through what would have been called by mathematicians as a brute force solution because of supercomputing. This has resulted in major breakthroughs potentially in drug discovery, and he has now moved from predicting the shape of proteins to now tackling how to have targetable drugs by partnering with chemists in Hyderabad and Bangalore to try and see how this can be done. So here is an example of supercomputing applications which are very narrow, very focused, but has made a major breakthrough. So let me start with our panelists. Let me start with Manoj, sorry, all the names mixed up. Manoj, what are the top two things which you would invest on to using supercomputing?
Yeah, one of the things that comes to mind is that a supercomputer is a very big investment. 4,500 crores is quite a lot, and the main thing that comes to mind is investing in performance. That's what I would think of. And I would like to see that we have the right kind of software, and the software also performs as per the hardware that is deployed or that is available. That I would say that's the most important thing. And to me, the faster you can run, the more power savings. The best way you can extract the parallelism that is there in the supercomputer, and that's not no mean task. So a lot of time and effort, I would say, would have to go into optimizing these applications, because it doesn't mean that the theory by itself will lend itself to the computational hardware that is there. And I was surprised that today nobody even spoke too much about these things. But that I would say is a very big investment that needs to be made as to how we can get the software to run optimally on a given set of hardware resources. So that I would say, to me, is the top priority I think we should give.
Yeah. Hi. First of all, let me thank you for giving this particular opportunity. So I'm Ravi Kumar. I am from Infosys. I had the Advanced Engineering Group. The two top applications I would look at is essentially one from the industry side of it. In fact, my earlier panel member Punendu has alluded to, this is more towards the industry 4.0 and the manufacturing sector, where now the most of the manufacturing industry, manufacturing assets are getting connected to the IT systems. That's basically the IT OT integration that is happening now. Because of that, you are able to get the data from the machines real time and use this particular data real time, analyze, predict, and prevent any kind of eventuality that are going to happen in the future and things like that. Whole industry is going towards it mainly because of two broad reasons. One is to improve their efficiencies. These efficiencies are the operations efficiency or the maintenance efficiency or the energy efficiency or the service efficiency related stuff, or to create new services and new products. Okay, that is basically the next generation products and services that they are looking at. All these things are tied to the performance of the underlying application that you are developing. How good that application is. One is the performance, the other one is the variety of data that it should be able to pick it up. Okay, some data coming from the devices, which is basically the sensors, some are coming from the video feeds, some are coming from the LiDAR devices and things like that. So multiple things that are coming here, which need to be processed real time. It's essentially capturing or reducing the gap between the event and the response time. Okay, that's where the biggest benefit that you get. It is essentially a typical manufacturing engineer looks at operational equipment effectiveness, the OEE. Okay, so currently the OEEs of a manufacturing industry close to around 60 to 70%. Now, can we take this OEE to 80 to 90% or so? Because each percentage means a kind of billions of dollars opportunity for a large manufacturing enterprise. So that's where you get a very big value that is coming, and because the kind of investment that you're going to make in terms of the high performance infrastructure and things like that, you need to have a sufficient value generated out of it. Otherwise, it doesn't make sense. So that's one. The second important thing is just extending to what Dr. Vijay Raghavan has mentioned. This is on the biomedical devices segment. So it's basically when these new devices, something like a stent deploying in a human heart. Okay, so if you want to make it personalized, that particular stent and deploy it and doing a lot of these multiphysics simulations, which is essentially a structural fluid flow. And of course, there are certain other things that you need to look at, electromagnetics, thermal simulations, and things like that. If you want to do such kind of simulations much faster and much better, and make sure that the person who has been deployed that particular medical devices, he is almost equal to the strength that he had earlier, original strength and things like that. So if you're looking at it, that is very, very another important application. That's basically the biomedical engineering space. Okay, these are the two broad areas I would say where HPC can play a vital role.
Chandru, by the way, in this discussion today, we have Vijay Bhatkar, Vijay Saraswat, Vijay Chandru, Vijay Raghavan. So all of I have to call someone Vijay.
Vijay, right, of course. Right. So I think, first of all, I think we're all here today because of something called Moore's Law, right? The supercomputing mission, or the whole idea of being able to compute at supercomputing scale. Now, just to think about it, 1958 was when Moore's Law sort of started, right? The first company registered to do semiconductor work and so on. And so since 58 to 2017, roughly the calculation shows that we have reached about 2 to the 40 times speed up, right? Now, so we are in the second half of the chessboard, and that's why we are seeing the singularities that we are seeing, right? Things are getting, happening much faster than we anticipated, and so on. Now, there's another exponential law, which is sequencing of genomes, right? Now, that has been actually accelerating as well. And since 1985, when the first Sanger sequencers were built, to today, we have reached 2 to the 32 times. So we just entered the second half, right? So that's why this morning, Mr. Narayan Murthy mentions genomics, mentioned the fact that his genome has been sequenced. Now, 4 or 5 years back, when his genome was sequenced at Philips, I think analyzing the data that came from that sequencer was a challenge, right? Today, with supercomputing capability, it can be done in anywhere between an hour to 5 hours. You can actually do the stochastic dynamic programming problem, parallelize it, run it on a GPU, CPU hybrid scheme, and get those types of results. And then the interpretation will have to be carried out as well. Now, two applications, or one application that really stands out today is neonatal ICUs. So, children, babies that are born, which are in critical, situation, it turns out that in many of the cases, maybe 20% or so, there is a necessity to probably sequence their genomes to know exactly why they're not thriving, right? And today, the world record is that they can collect the sample from the child and give the medical advice in 36 hours, right? In order to do that, the actual computational tasks involved have to be completed in something like 1 hour, right? Now, that can only be done with the right kind of supercomputing infrastructure that we are talking about. And if we think about 23 million births in India per year, there's a large number of such cases that need to be solved, right? So that would be a very exciting application to drive NSM types of work. The other area that really excites me is computational epidemiology, which is more biostatistics. But today, our ability to predict epidemics, outbreaks of dengue or chikungunya or flu, and we are really reactive. I think Vijay mentioned it today. We solve problems, but we are not able to do preventive intervention when major problems occur, right? And how do we move towards that? You'd be surprised today, for predicting flu outbreaks, Google Flu Trends actually does slightly better probably than CDC, right? And it does it by collecting social media information and analyzing it and building predictive models based on that. So I think a very, very exciting area that can become a reality with the NSM kind of infrastructure is to move towards digital epidemiology in this country. And
Thank you very much. Jayant?
Good evening. I come from a little different industry, and I would try to correlate two specific examples. One more from the project kind of setups and those organizations which are large areas, very, very large, let's say, infrastructure kind of a project. And second is direct applicability to the armed forces. if we really look at on the armed forces today, bulk of the armed forces are across the world are getting networked. With an IP, you're assured of certain level of security, but even today, for a fire control computer, what physically has to go in is based on local area. A balloon would be put up, and the weather data based on that balloon with lots of latency, there would be a firing that somebody will attempt, and for no marks to guess, it will never be correct. With a kind of a supercomputing solution available, one can actually pull in the weather model, one can actually pull in the layering model, solve and provide a precise information, and then the same shell or the same rocket would perform 10 to 20, 30 times more accurate. So you won't need tactical missiles, you can do it with a gun. The amount of enhancement in terms of ability to spend least possible force, get maximum possible effort in terms of effect physically produced at lowest possible cost. And that's something with a completely IP networked scenario. And today our own armies are actually building these networks. The networks are coming in, the IP network is actually getting built, C4I is coming in. All that it requires is a great computation engine which actually brings in heterogeneous data which otherwise would not be at one given place. From Met comes, meteorology department would bring in one data, completely different data from another place and be able to provide a soldier an ability to select his target, and if he selected a wrong target, by first fire you reveal your position. Instead of that soldier, somebody else may actually be able to provide a data to a person to fire so that there's maximum effect. Again, you kill before you actually have to fire. So those are kind of applications I see dramatically improving life in the defensive kind of postures. What Indian, let's say, government normally is never on the offensive side, it's always on the defensive. Second, I talked about completely different kind of a domain, but let's say you have a 1,000-kilometer infrastructure project, and my company does get involved into those. You have assets all over. You just don't know what asset is doing what. Is it getting utilized? It is not getting utilized. Now you pump in capex, you want certain performance out of that capex. Each performance parameter out of each of these machines, which are lying right across, you actually can have on a one single location. Today, if the computation power is a limitation, but if you have a computation power, you actually can decide how much is really needed, how much is not needed, what is really being used efficiently, where is it getting idling. And this can do wonders, not just for a company like mine, but now imagine this kind of data being available, you know, where all there is a waste. And the waste is ultimately a national waste. We can control whole lot of what is happening. So just two applications, completely different domain, but I see on asset ownership, dramatic performance improvements for right across the national assets which are being used. I'm just giving an example of one company.
So I would look at this problem a little differently. I would look at it more from a system software perspective, right? So I will not look at it from an application software perspective, because first thing I would like to understand is whether you're trying to democratize the access to this or you're building this for specific applications, right? Because when you look at it in two ways, the way you go about building the system, access to the system is very, very different. So I think that I would like to understand first. Post understanding that, what I would then do is look at what needs to be built on top of what is existing in the open world today, right? An operating system might change, compilers might change, programming languages might change, databases might change, because today you have a lot of unstructured data and you have Hadoop and other distributed databases. But if you're trying to democratize the access, then you might want to think about this very differently. So hence I would look at what is required in terms of the system, what is this being designed for, and then enable it, then applications will come on top of it. It's very, very important to identify the applications, but providing the system software on top of the hardware and also enabling, like if you want to democratize it, then it has to be AWS equivalent, and that is not easy, right? You need to have a lot of software that is out there where there is easy access, as opposed to someone going and physically accessing the system. So I would look at those aspects and then be very clear on what is that we need to do to enable people to use the system. And then a few applications, like all my co-panelists have said, those can run on top of this. So that's what I would look at. Yeah.
Sure. Thanks. So hi everyone, good evening. I'm Jigar from Wipro. I'll bring in a different perspective, a little different than what panel discussed about, right? I'll divide the problem into two, as he said, any two problem I can talk about, right? So in knowing NSM investing good amount of money on software, and software is the one which everybody is discussing, deriving the parameters for hexascale. I would, one, take a selfish approach, which will in turn help NSM and the nation to get money back in the ecosystem. And the second, which is in the public interest, which will help the larger audience, to each individual of Indian, sitting anywhere in the corner of the country, helping them with the NSM facility. So the first approach is industry-used softwares, right? Can I target them? Because they are the same software which has been used by the government bodies as well, right? Talk about, say, CFD or bioinformatics, right? I would first target those applications, because that's where even industry has the interest into, right? ANSYS software or a Hyphen software or a Abacus software is used by everybody. Talk about defense, talk about ISRO, talk about Wipro, talk about any other company who does simulation, right? I would first target those kind of application. I would go all about it. And as we talk about, NSM has fundamental thing been defined as open architecture or open source based solution. This will help not just industry, but will also help the government and the rest of the community who wish to use this particular softwares. The second way I would look this problem statement to be solved is helping the mass. The hot topic got discussed just before the panel discussion was on Aadhaar. And we see everything getting linked. A lot of joke also comes around this, right? What we talk about, everything is getting linked to Aadhaar. One of the topic we were discussing just before the panel discussion in the tea was, why can't we link, say, our DNA information with Aadhaar? Why can't we link our personalized medicines, which is going to be reality pretty soon, with Aadhaar? This data will help to an individual when he or she is in trouble. Say an accident happens, a hospital needs that particular data. The hospital will have complete data of the individual on how that person has been treated before, right? And what precautions I should be taking care of about it. Or he has a particular problem, like he has a diabetes or cancer or something else, that may help me do the right preventive steps when I'm doing the operations. So I would solve the problem at a larger scale by using, say, weather or a biospecific problem statements for the larger audience using the NSM facility. And certainly the first aspect, which was the commercial side of it, which will give the money back to the ecosystem as well, because industry will equally be interested in developing them and using in-house to save their own cost in their own projects, right? So that's the two perspective I had.
Yeah. Yeah, one idea I got from one of the speakers who spoke just now was about brute force, and that triggered my own experience. We were developing an application, an optimizing application for an Australian power company, because they were losing their money because of so much of solar panels coming across the country. So we had to help them build a new billing or tariff structure so that they could keep their revenues the same no matter what. So that meant that the billing or the tariff structure had to have a lot of parameters which had to optimize and look at the usage modes of or the usage patterns of electricity across the country, and so that you change the weights of those parameters so that you can get the same amount of revenue. Now, what required was basically, it was a mathematical optimization problem, which is usually done using various algorithms. You have hill descent, or you got linear programming, whatever the way may be. Now, everybody knows about these algorithms is that they may give you a certain minimum, okay, but you may not get the exact minimum. There's always this question of global minimum or a global optima and a minimal optima. So while these algorithms may really give you a very good amount, but sometimes when you say brute force, a very simple idea that comes to your mind is to, why not just try all these solutions, given the feasibility, of course, try all possible feasible solutions. And if we have a very large SPC infrastructure, it may be just very easy to do that. So for this company, just by using a GPU and a brute force search, we were able to save them about $400,000 of revenue per year. And that's probably not a small amount, but there is a chance of using HPC hardware for using just brute force optimization, because if that means a lot to the business, that global minimum means a lot to the business, it's worth spending the HPC infrastructure that you have to do a brute force search and lock into the global minimum. Sometimes it may be a big bang for the buck. I cannot offhand think of all the applications that might be useful, but this is just as an idea that strikes to my mind. Thanks.
Thank you. It's actually quite striking how, cutting across different themes, the kinds of tools which we're discussing to develop from the computer science, both hardware and software perspective, seem similar. But there's a challenge here. We, in some ways, we heard mention about the life sciences, but every domain has a deep domain knowledge which comes with these computational tools which we need to do. And the key to success as industry in society is to bringing these two knowledge groups together. And one of the points we were discussing is how difficult it is to find people who are very good at both. We can have people who are superficial at both, but finding people who are very good at both is a challenge. So is there a room for knowledge-based industries, distributed, started by entrepreneurs, who have deep domain knowledge in some area, but also have access to the supercomputing facility and our top computer scientists, so that bigger fish, like those seated on either side of me, can hire these companies to get specific problems solved? So that was my second question.
Yeah, I was. This is possible in the sense that there has to be a certain collaboration model. Every success story in HPC, if you look at these Gordon Bell Prize winners every year, you see what you see is a multidisciplinary team. The domain scientists, the computer architects, all of them get together to solve a problem, and what you see is a big achievement. So it's this kind of collaboration that is required in order to see a success story even in supercomputing projects. Without that, I mean, it's a no play. Another possibility is to be a know-all, but that only comes with experience. You may grow starting to be a domain scientist or to be a computer scientist, but as you keep growing in the domain, you will learn something, and there's possible that you maybe do it. You may be a know-all, but that's a very remote chance of success, or you may have to wait a long time to see that happen. So that's why I think collaboration is key to making this possible. But if you get into a kind of lockup where you think, okay, this is my IP, nobody should know about it, or this is my trade secret, nobody should know about it, then you're in serious trouble.
Thank you. I look at this particular problem in two ways. One is the technology layer. Okay, that is basically the HPC technology layer, how to develop an HPC application from a software development methodology and the technology perspective. Okay, both the software as well as the hardware, there's a certain amount of hardware associated with it. Okay, which is more or less common across the industries. Okay, which can be shared. The best practices can be shared across. The second layer is essentially the domain layer. Okay, this domain layer is used to develop specific applications, whether it is in the health sciences side of it, or in the manufacturing, or the financial sector, or in the utility sector. Okay, so there probably the knowledge cannot be shared that easily as the technology layer. So probably there, the companies who are working in that particular segment, they can form a small group and make sure that whatever that can be shared within their organization or within their group, that can be taken. And of course, there are specific knowledge that is there, which is very, very specific and core to the company. So essentially, it boils down to two things. One is the specific knowledge, the other one is the generic knowledge. So generic knowledge should go across the board, and the specific knowledge can be with the companies. Yeah.
The reason I'm asking this question is there a threat that if you don't have this combination of domain knowledge and the generic knowledge, that all these investments will be to naught because you're going to have global competition which has this combination?
Right, thank you. I think this question was tailor-made for, for Strand. So, it's actually been an extraordinary experience of building this cross-disciplinarity, where we've had about 100 biologists, about 70 computer scientists work together at Strand. And it's very hard to do this, and you're required to do this in smaller companies. I think this agility that one can have in smaller companies is very important to be able to get across these silos. And I think there's a great opportunity here to actually, I talked about genomics. Now, it is predicted that by the year 2025, we will be generating more data in genomics than in astronomy, right? So we will not say it's astronomical, we'll say it's genomical, right? So I think there is actually an extraordinary opportunity for a KPO, knowledge process outsourcing, for India to become kind of the capital of the world in knowledge process outsourcing in genomics, right? Now, how we get around to doing that, what is, how the large IT players, combine with players like ourselves, and how we leverage this entire infrastructure is obviously a great opportunity, and I do hope to see that.
I see this to be a bit of a cliche. And why I say that is for a reason that what is domain is tomorrow's commodity. And that's precisely where, depending on one's position on the learning curve, all the past mistakes is where the domain really comes out of. Now, a lot of those past mistakes, very systematically collected, actually system can throw far better solutions, and that's exactly what we talk of artificial intelligence. Now that's one aspect of it. Beyond that, the ability to think through first time would always be something which would need to be basic training of people. And I see that although these kind of tools and enormous amount of data being available, and in a matter of second one could get that analytically validated and then act on it, there'll always be that, call it the sixth sense. And that sixth sense will probably need to be developed. There's no shortcut solutions. It would need to be built into people. And if one is investing enough in people right upfront in their careers, one actually would have people who can be retrained. I'm personally a very firm believer that a good material, irrespective of where they are, at what stage they are trainable. And they would actually do that.
So I'm from the startup world, and my experience, like what Chandru is saying, is any innovation always happens with a very small team. You never have a very large team for anything new, very good to come out. It's always a very small team that works on it. I don't know, Vivek can tell, an Aadhaar, probably an 8-member team, or when Chandru started Life Science, it was 5-member team. So the core is what is most important. And once you build the core, you get people with relevant experience, and you have to train them, because you'll never find the exact match. It doesn't matter what you do, there's never an exact match. But the core is what is most important, and once you have the core and that is done right, then hiring the people, and then with reasonable match, like 50-60% match, and then training them will become a lot easier. But the core is where you need both the domain expertise and the computational experience, right? And the other thing we're observing now is the new wave is where there is intersection of domains. And it's just not one domain anymore. It's whether biology intersecting with computer science, neurology intersecting computer science, agriculture. So you are going to see a lot of that happening, and that's the new wave that we see. But I think you'll find the core team to do it. Otherwise, innovation will stop.
So while I shake hand with most of the discussion which has happened, another perspective to it is it's a chicken egg story as well. Until you will not have demand, you will not have the supply as well. And if you see the morning presentation when the HRD part of the discussion was happening, from the 4 panelists, one of the point which was being debated was it's been categorized into 3 buckets. Smaller trainings, medium trainings, and the larger trainings. And the goal is to do bigger at a scale. The reason is because the larger scale is coming up as the NSM will get implemented, right? And that's when the demand will be generated and supply would be asked. And if we are not ready, then we are in trouble, right? If you see today's ecosystem as well, I mean, talk about the biggies, say Wipro, Infi, TCS, they run a 6-month training program in their campuses. They have a special campuses only to run training programs and all. What the raw material we get in engineering is Java and .NET, right? The reason is we are a software-driven country. We are known for it, and that's the demand. We have been seeing it all throughout the years, at least past decade, right? But if you see the next wave of generation that has been demanded, and if you see the other countries, how they have been designing their curriculums as well, is that they just don't teach the HPC and the domain. They also teach you the data science, the AI, the deep learning, so that you are ready for the next generation of wave as well, right? And when you finish that decade is when you are, knowledgeable enough, or you are matured enough, or so-called the experienced enough to take up the next wave of generation, which cannot be taught into the engineering course any day, because you can't predict beyond 10 years in IT world. And then, build on top of that and survive for the next 20 more years, right? And of course, the last 10 years are typically managerial or, higher responsibilities and stuff. So in my view, it's a chicken egg, it's a demand supply, and probably NSM is going to be the right platform, as that we know we are generating a demand, at the same time we are generating the supply as well. So both has to work in hand and in parallel.
So, last question to the panel before we throw it open for discussions. And this relates to, again, capacity building. One of the impressive things about all of you is how you have built up your structure so well. And that gives you a certain level of confidence about how to deal with the present and what to do. Is there a danger in this confidence that you are not prepared for the unknown unknowns? And how can you be prepared for the unknown unknowns? One possible way is using computing on scale in our population to democratize it so that it's accessible at quality to a large number of people. And therefore, statistically, any problem you want to solve, there will be some set of people who can help solve that. One secret weapon, which I don't know whether it's mentioned in the previous discussions, is, and I didn't mention this in our discussions earlier, is that half our population is essentially not represented in this room. Can we bring in quality computer science and IT education and training, including supercomputing, which will become the norm, to women on scale, so that, along with men of course, so that we have a large population who can throw up answers to every kind of problem we have. This is a surprise question, so we didn't discuss it.
Okay, I think we have, when we invest into so much hardware, there should be enough access to everyone in the country. It's just that, and now there's been so much talk on Aadhaar, just that everyone with an Aadhaar ID should be able to use the supercomputing facility for themselves. So I personally don't see much of a challenge in that. Well, that's my opinion. I'll then just hear the other panel members and refine the next round.
Yeah, I will look at it this way. So if you are looking at building a scale, there are two things that comes to our mind. One is the people, the other one is the infrastructure that is required. Okay? People, if you look at, in this technology space, the only thing that is continuously change is the change itself. Okay? The technologies are getting changed day by day. So it's essentially boils down to the learnability part of that particular person who is going to quickly learn and use that knowledge to develop applications and things like that. Okay? So that, if you look at, there are two ways. One is basically the existing people that you have. these people have to be reskilled or the multi-skilled kind of thing. The other set of people are the new people who are going to come into the stream. That is basically they get trained in these new technologies and things like that. Then the second important point is on the infrastructure side. If you look at the high performance computing infrastructure itself, it is pretty expensive. Not everybody can afford. Unlike a typical Java, .NET kind of skills where you just get onto something with a very minimal investment, you'll be able to understand, learn and things like that. Whereas HPC kind of thing, it requires a huge infrastructure. That's where I think NSM and other societies have to come forward to provide that kind of necessary infrastructure and utility. I mean, it's something like now internet has become more or less utility. Similarly, this infrastructure also should become it should be like utility. Then a lot of people can get trained and then we can build the scale.
Yeah, so I think the question was actually about gender, right? And and how we can get more women involved in this whole sort of computational enterprise, and I think clearly there is a gender bias at Strand today. We are 55% women and 45% men, but in the computing side, it is 70-30. The males dominate. On the life sciences side, we have more women than men. So but there are some obviously very skilled women in computing. But I think what Vijay is asking is a much bigger question. That is, how do we actually empower this large part of our workforce to actually participate in something like an NSM, and how can training and interest be engendered in women in computing, and actually computing can be I mean, there's no reason why it has to be gender biased, right? There's nothing specific about it that makes it harder for one versus the other. So I think we have to give it some thought and and figure out how to do this. I think certain types of flexibility has always been helpful in bringing more women into scientific disciplines. So I think this is a social question.
So I'll sort of quickly give a very short view from my side on this. One of the characteristics of success in the IT industry is the kind of way by which small groups of people get together and intensely work over long periods of time during the day. I think there's an opportunity for the supercomputing mission in terms of the HR programs it develops to have places where women are comfortable doing this, on scale, so that these kinds of opportunities in our social context across our spaces become more accessible naturally to women in a manner which they are comfortable yet have access to the best quality interactions. Those are feasible. Many of those ideas are being discussed on multiple levels, but I think we should try and see how we can take that along.
I don't think it's a question of whether. It's a question of a sheer matter of a decision to actually implement. What you just mentioned about the IT sector, it's a decision of an IT sector that there's as much of intelligence and as much of abilities which actually can be contributed. One can't really say that on many other domains, but we have an experience of women actually supervising men of twice of their age in a workshop environment in heavy industry, and they do amazing piece of work. The disciplines on the whole place, they're dramatically different. So when I say this, from design offices was always taken for granted. Women are able to actually do the 3D special thinking far better than lots of men. I mean, I'm making a statement. Obviously, I'm not trying to say that the men are not good, but the ability of imaginative work, women can do far, far better. And that's exactly where I don't see it's an issue of whether, it's a question of empowering and getting it done.
I don't know whether you've seen the movie or read the book on Hidden Figures on computation in the early stages of NASA. And as computer scientists, most of you would have heard of Linda Lovelace. So it wasn't that the computer science fraternity didn't have prominent women in there.
Yeah, so the way I see it is the education and the training paradigm is changing, right? Everything is becoming virtual. One example is Andrew Ng's course, right, on ML and deep learning. He is democratizing it, and tens and thousands of people are taking it online. And when you need somebody who has knowledge of ML and deep learning, if someone has done the course for 4 months, you would hire that person. And the beauty of that is you can do it anytime you want, any time of the day. So I think women will be very, you're sitting at home, you take it at whatever time you want. If it is 9 o'clock in the night, do it at then. If it's 6 o'clock in the morning, do it then. So I think the paradigm itself is changing. So hence I think both questions that you asked, one is training more people, and second one is whether we can get more women. If you go with this paradigm, you will affect both, because it is democratized across, and that's where it's going to go. It's evolving towards that.
Yeah, so I'll answer both English, which is coming out from the question, right? Firstly on the technology side of it, and I was initially part of the UID solutioning part as well from Wipro side, and I'm taking good example of UID again because it has been discussed too many times, and that's the only example we have which has broken so many things as technology disruption which India has taken up, right? So it's just breaking the ice in my mind. When we talked about it first time, at least in Wipro campus, and to tell internal story, which is nothing to disclose, technical part of it, we were like, 3x the hardware? Are we kidding it? We are never going to win, and we are never going to be L1, right? These phenomena of winning and making sure that we are in the game, right? But when we heard the external person who came from Yahoo to US to us for the first time, what this technology is, why UID is thinking of going behind big data, and that's something what a traditional database can't do it, is when we realize the power of what big data can do it. And if you see today, any of us who is sitting in this panel has probably the largest practice in their company on big data, deep learning, advanced analytics and stuff, since then and today. Look at all government projects, starting from healthcare to financial sectors, to entire GST and implementation, all banks, everything is on big data today. So what are we talking about? We are talking about just breaking ice on thinking whether this technology can make a disruption or not. I deviate to one of the statements made by the panelist. The reason behind that is I've seen personally selling this hardware story as well. Today, compute is far more cheaper. The idea is a costlier thing, right? I know CDAC has a very good initiative on Param Shavak. It's a mini supercomputer in a workstation which comes, they sell it to many universities for running the courses and stuff. In my view, compute can be done on that as well. The only thing is the outcome will take time. Just that if the idea clicks, then I'm sure you will find the investor who's going to invest into it and you will have supercomputer on your hand. On the women empowerment, in my view, HPC is the best way to have women empowerment. The reason behind that is most of the work is sitting job, right? And there is less mobility in place. Be it parallel programming, be it server monitoring, be it infrastructure building or testing these systems or benchmarking them. In my view, that's the best profile a woman can have it. And I personally can tell it because my wife works in IT and I can understand what problem statement she undergoes. So it's simple.
Thank you. Yeah. Okay. Quick last point and then questions.
So the quick point is at Infosys, we are very good at diversity. Okay, close to around 40% of our workforce is women. Okay. The only problem that we see today is as they grow higher and higher, the number of women is coming down. The percentage of women at the higher ups is less. The reason for that being, after some years of working, their family becomes their first criteria and things like that. And they have to take care of the family. So in case, if you are able to bring those people who took a break in between and then want to join, so we should be able to provide that kind of facility, then it will definitely add a lot of value. Yeah.
Questions over there.
Hi. Hi. My name is Srinivas Raghavan. I represent the AI and data science function for Infosys. I've been listening all through. Very exciting day for me to learn a lot of things. I'd like to congratulate the founding fathers of NSM for making us dream big actually. I would like it to become a movement actually from a mission.
Specific questions to this panel.
Yes, I have 3 questions. Two to
If you want to ask 3 questions, the thing to say
very simple questions. Very simple questions. Two addressed to Dr. Chandru. I would like to know if the era of NP hardness is going to end. The second one, yeah.
I think the theoretical, challenges of complexity in computation is, we keep pushing that boundary, right? So today we solve million node traveling salesman problems and so on by using all kinds of computational tricks. And will we be able to brute force our way through some really hard problems? I think Vijay started out with an example of such a success, right? But it takes a very focused effort for each of those problems, probably very specialized hardware. So protein folding, you have to get the quantum chemistry right, and so on. So I think it can be done. We can make NP hardness irrelevant, but it'll be problem by problem solutions, and it'll be very hard.
I must go to the next question. We are running out of time.
Sandeep Garg from ISA. Sir, I would borrow the point Mr. Patil made on the ecosystem and the type of the problems you have. Let me narrate all the federal structure. The problems are all similar. You take urban transport, you take water pumping, you take municipality, you take any situational. I think the application software needs to be devised around the problem solving attitude. And if we go into too depth and too wide of a network, I think the problem solution is not going to occur. My request to the panel is, I think these are the basic nuances of problem solving, and where the problem and the situation parameters are all same. If you have a water logging here, we are not been able to solve that problem, and the computational forces required is to do that solve problem. Same problem is in Delhi, same problem is in Bangalore and Mumbai, everywhere. I think the problem in application software about the supercomputing mission should be solving those pieces also.
Yeah. Yes. Dr. Nayak, and then, please.
I've been talking about computing as a utility for last 8-10 years. Okay, somehow this idea of computing as a utility is feasible and it can be done. But NSM can give a seed. Somehow I feel that project can execute and you can give a computing as a facility. But either since all three, Infosys, Wipro, and L&T is there, can anybody put in money later, I'm talking version 2, and commercially exploit this computing as a utility? Because we have got a huge mass of people. We are saying about 1 million engineers. We are producing even 10% of engineers, 1 lakh engineers use it and become entrepreneurs. It's going to be a disruptive technology sort of a thing. Are there any willingness from this? NSM will start the process of putting in computing as a utility, later exploit by the private from a commercial angle. Is there any view from that?
Sorry, I'll answer. So I'm sorry if I take the name, but you're asking Mukesh Ambani, I'll put the towers, will you sell the SIM cards or not? Why would we not? Right? You have put the base infrastructure, you have put the ecosystem in place, you are giving us money to develop those softwares, not fully, but partially, also giving us raw resources which will give us as an input, engineers, infrastructure, cloud, or whatever setup that you will give it to us, and the full ecosystem which will come from these institutes who is going to do the research, make it as an end product, which we will be able to sell it. I'm sure we'll be very happy to do it because this is pure business in my view.
Excellent. Good.
One liner.
One word.
That's it. Your question had an answer. For all of us in business, time is money. If we can save that 3 days, 5 days, 7 days of simulation in matter of minutes and seconds, we would be stupid not using it. Yeah, exactly. That's exactly a chicken and egg syndrome. Yeah, absolutely.
Next metaphor is chicken and egg and bootstrapping. Okay.
This is probably going to take us to some answer to that question, actually. So, I think you mentioned about how, the computational scientists and computer scientists have to come together to actually come up with some very efficient HPC, setups. For the fact that, the domains are actually, people would have slogged nearly, decades to actually get to where they are. And similarly, on the computer science side, people like us, who have spent 3 decades plus on the computer science side of things. So it's very difficult to say that a computational scientist can be as effective as a computer scientist over a period of time. So this is exactly what I again give the same example of working with Professor Rodam Narasimha, and so we have really come up with some very exciting results. So and I also want to say that we are one of the 10 code modernization partners for Intel in the world. Which is essentially parallelizing and optimizing HPC applications. So please make use of companies like us.
Thank you for that advertisement. Yeah, next. But actually you have a very important point. That experience and domain depth needs to be scaled and widely used, but go ahead.
I'm Prathu Tiwari from Wipro. I have interacted with researchers and developers and programmers. Is there any idea? My question is to you.
Me?
Yeah.
My God.
Is there any idea to develop a repository of ideas and the codes? Because I see that a lot of researchers do good research, and when they pass out, the code is lost.
So
developers.
Okay. So this is a broader point about the way science and research is catalogued. Yes. The current systems, in many ways, I'll be very brief, is broke globally. Yeah. In terms of the time taken for publicly invested research to be publicly available. So this is a very big debate, not just in India, but everywhere in the world, about how can the results, both negative and positive, of public funding be generally available. That is happening at breakneck speed now. So you will have search engines and mechanisms to find out not just nationally, but globally what is happening, because the metrics of evaluation of success in science will no longer be the conventional ones which put a huge weight on individual success as opposed to community benefit. As those metrics change, data will be available more rapidly. So that's happening, both in India and abroad.
I'm Mahesh from BEL. Is there any thought process to include a blockchain technology to improve the performance of the supercomputing?
Sorry, what technology?
Blockchain, the distributed ledger kind of a thing.
Yeah, Chandru is a world expert on blockchain.
I'm sure our friends from the IT companies will know much more about this. But yeah, certainly for secure data, I think blockchain today is perhaps the technology that most people are going to, surprisingly, even in genomics. So it's just starting to happen.
So this is one thing I don't see coming up in HPC for sure, because there is recent research which has been published, and I can refer that paper to you. But whatever it may be, a blockchain implementation, the fastest blockchain implementation, doesn't scale beyond 8 servers. And the maximum throughput you can get out of it is 1,000 transactions per second. And there is no way today, by adding more and more hardware, it's going to scale further. So let's just forget it for now.
Okay, on that happy note, let me just ask each of the panelists in 10 seconds, summarize, less than a tweet, summarize what they think is the take home about software and supercomputing.
Yeah, for me it is like, if I have to put it in a very short word, right? I can push water through a pipe, okay, but and water adjusts its way to whatever network of pipes it is, and I would call that performance. But if I have to think of software running through a set of hardware to give me that performance, it's not that simple. So I think we need to invest a lot into making software flow like water, if that's what I have to say.
For me, supercomputing is one of the technology axis. But actual one is, as you rightly mentioned, it is the business problem that we are going to solve. That is very, very important because at the end of the day, a problem that we are solving, that problem need to be solved using multiple technologies. And if supercomputing is going to provide a lot of value, definitely you need to pick it up and use that particular technology.
I think, as Srinivas Raghavan was asking, I think we probably need to rethink algorithms, in the era of supercomputing. But at the same time, I think also we need to think about how this whole era of data, systems, and society interacts. And in many ways, I think we are entering an age of cyber-physical systems. And so a lot of our thinking, thought process now has to be built around that.
A great initiative, and obviously, to my mind, the true success will depend on how do we build the in-between connectivity. How do I pass on data? Because we have gone away from mainframes. It's no longer going to the mainframe. So the accessibility from where I am is going to be the key technology, and that's what will really make it success.
Understand the problem you're trying to solve and design something that's open.
So in my view, 2018 same conference will talk more about domain and software only. Hardware will be incidental, is how I see supercomputing evolving over next few years.
We're done, but okay, you have the last word.
So I just wanted to share, Ananta from Caligo shared about the HPC computing work that they have done, and from either side we would like to see them at the ISA Vision Summit in February, and we would like them to showcase what they have actually implemented, because it looks very exciting and directly relevant to the NSM project. And we would like to see Dr. Saraswat, Dr. Nayak, and a lot of you there to see that and build up the next edition of this particular.
Thank you very much. We are running late and it's not fair to the next panel, but thank all the panelists very, very much, and thank you all.
Thank you so much, sir. I'd like to request Dr. Vijay Raghavan to hand over memento to all the panelists, please. And also would request them to kindly stay back for a quick group photo. Our next panel is on exascale computing. Requesting ladies and gentlemen to please stay back. I'd like to request Mr. Ashwini Kumar, our Chairman IESA, to hand over memento to our chairperson, Mr. Vijay Raghavan. Dr. Vijay Raghavan, sorry.